Let's start with the analytical method. Yesterday we have discussed about the core ideas of differentiation and the numerical method. So today we'll start with the analytical method. So yesterday we have discussed that what dy by dx means. Dy by dx is a ratio of the infinitesimally small y by the infinitesimally small x, or also you can tell that dy is a small change in the y direction and dx is a small change in the x direction. Differentiation ideally means that dividing a finite quantity into very small fragments, and these fragments are infinitesimally small. And if I draw one, let's say some length I have drawn here, it is having some finite length, and if I divide the entire length into very small fragments, and these fragments are infinitesimally small, that means ideally we will get infinite number of fragments, right? And differentiation means that I will divide this finite length into infinite number of infinitesimally small fragments, so that the length or small length of each fragment is dl. That is infinitesimally small, that means it is almost close to 0 but not exactly 0. That is the meaning of the differentiation. Again I am telling the differentiation meaning is fragmentation of a finite quantity into very small parts, and each part is infinitesimally small. If there is some volume, finite volume V, and if I divide the volume into very small volumes, then the small volume will be denoted as dV, but dV is almost close to 0. The volume is almost close to 0. Same thing applies for area, same thing applies for force, same thing applies for any other physical quantity which I want to use in our problems. Okay, now let's say I have given you one function. Yesterday we have discussed about analytical formula of one function differentiation, that is y equal to x to the power n, where n is any number. Then I told that, just now I told that dy is a very small change in y, or very small fragment of y. Now dy by dx is a ratio of infinitesimally small y to infinitesimally small x. So dy dx, the formula is n will come in front and 1 will be subtracted from the power. That is the formula. So dy by dx you are getting this. So dy, or the small value of y, small change of y, is going to be n into x to the power n minus 1 multiplied with dx. So ideally I am getting, initially the relation of y was y equal to x to the power n, but right now we are getting the relation of small change in y with a small change in x. So dy dx ultimately is n into x to the power n minus 1. Now let's take one example, that is, let's say y equal to, let's say x cube. Then the value of dy dx is the slope of the graph at any particular point. Here is going to be 3 into x to the power 3 minus 1, that is becoming 3x square. And now if I draw the graph of y equal to x cube, we will be able to draw it like this. Y, this is the x independent variable along the x axis. The graph in the positive x axis will be looking like this, and the negative x axis will be looking like this. Very simple, because it is an odd function. Odd function we will not discuss right now. It is just asymmetric with respect to the y axis. It is the odd function. Now see, this dy dx, or the slope of the graph, is a function of x again. Y was a function of x as y was varying x to the power 3, but dy dx, the slope of the graph, is also a function of x. So slope changes with x. So slope I am getting as a function of x. That means if I draw one tangent here, let's say x equal to 1, I am drawing one tangent here, and if I tell you to find out the value of slope at x equal to 2, that means this is the point, you have to draw one tangent again. So see, this tangent at x equal to 2 is making more angle with the positive x axis compared to the x equal to 1. That means the slope is also increasing with the value of x. If I, let's say, tell you this is the function y equal to x, let's say, if I plot the function, it will be looking like this. The function will be looking like this, passing through the origin. Now see, if I tell you this is x equal to 1 point on the graph, this is x equal to 2. From the formula of differentiation, you will get dy dx is going to be, here power of x is 1, so 1 will come in front and 1 will be subtracted from the power of x, that is becoming ultimately 1. So that means you are getting that dy dx, or the slope of the graph, is 1, that is constant. That means if you draw one tangent here, this tangent, if you draw one tangent here, this tangent, they will be making the same angle with the positive x-axis. That means here the slope of the graph is always constant. Similarly, if I tell you, okay, y equal to x to the power 0. X to the power 0 means it is ideally 1. That means if I plot the graph will be looking like x to the power 0 means it will be parallel to the x-axis. That means wherever you draw the tangent, ultimately the tangent will make 0-degree angle with the positive x-axis. And by differentiation rule, dy dx of x to the power 0 is going to be 0 into x to the power 0 minus 1. So ultimately it is becoming 0. That means wherever you draw the tangent, it will always make 0-degree angle with the positive x-axis. Let's take the example of another function, very simple function, y equal to 1 by x. So see, if I rewrite this, I will get that x to the power minus 1. So y equal to x to the power minus 1. And if I want to draw the graph will be looking like this. Let's draw the graph. Y, this is x. Y equal to 1 by x means the graph will look like this. Okay, this is the graph. Now see, power of x in this case, in this function is minus 1. So if I find out the value of dy dx, that is essentially the slope of the graph at any point on the graph. So it is becoming minus 1 will come in front and 1 will be subtracted from the power, that is minus 1 minus 1. So it is becoming minus 1 by x square. Now we are getting that dy dx, or the slope of the graph, is minus 1 by x square. Now see, for any value of x, this term 1 by x square term is always positive. So ultimately dy dx at any point on the graph is a negative value or negative number. Now that means anywhere you draw the tangent, ultimately the tangent will make negative angle with the positive x-axis. That is the meaning. That means if I, let's say, draw the tangent here at this point, if I draw the tangent here, now see, this tangent is making negative angle with the positive x-axis. So this angle is called the negative angle because we are measuring the angle in the clockwise direction. In trigonometry, always we measure the angle in the anti-clockwise direction. It is a positive angle. So this is the negative angle. That means the value, let's say this is theta. So it's minus theta. So tan minus theta is going to be your value of dy dx. Now let us see one more interesting fact here. See, dy dx, of the slope of the tangent or slope of the graph at any point is minus 1 upon x square. That means if I increase the value of x, the slope will decrease, right? The slope will decrease, because if I increase the value of x, let's say from 1 to 2, at 1 it will make, or it will be steeper compared to at x equal to 2, because let's say this is x equal to 1 point. X equal to 1, I have drawn one tangent, it is making some angle with the positive x-axis. Now x equal to 2, let's say that x equal to 2 is this point. If I draw one tangent, this tangent is steeper compared to the x equal to 2, because this is making less angle, let's say theta 1. So theta is always going to be higher than theta 1. So as I go on increasing my x, the value of the slope will be going towards 0. As x will approach infinity, your value of dy dx will almost approach 0. That means if you draw one tangent at very high value of x, ultimately that tangent will make almost 0-degree angle with the positive x-axis. So now let's study this function y equal to log of x base e. So dy dx, or the slope of the graph at any point, is going to be 1 by x. Now let us plot this to visualize. This is the y-axis, this is the x-axis. If I plot y equal to log x, the graph will be looking like this. This is the graph where this point, where the y is becoming 0, that is x equal to 1 point. X equal to 1, it will cross the x-axis from the bottom side of the 2D space. Now see, dy dx is the slope of the graph is 1 by x. That means if I increase the value of x, if I increase the value of x, wherever I draw the tangent, that tangent will start making lesser and lesser angle as I increase the value of x. That means if I draw one tangent here, let's say it is making some angle with the positive x-axis, and if I draw the tangent here, it will make less angle with the positive x-axis, because the graph is slowly becoming flat. As x is increasing, it is becoming flatter. So that is the tendency of the graph. And when x will approach 0, that means maybe here, somewhere here, when x is approaching 0, that time you are able to see that if x approaches 0, this 1 by x term is going to be very huge, so it is almost infinite. That means if you draw one tangent on the graph which is for a very small value of x, that tangent will make almost 90-degree angle with the x-axis, because as dy dx is infinity, that value is going to be your slope of the graph, and theta becomes 90 degree. That means it will almost make 90-degree angle with the positive x-axis. That is the trend of the graph. Now let's study this function y equal to exponential x. The dy dx value of exponential x is also exponential of x. Now if I plot this graph, exponential of x, the graph will be looking like this, exactly like this. So see, if the function is exponential of x, its slope is also exponential of x. That means if I draw one tangent here, at any random x, if I draw one tangent here, this tangent is making some angle with the positive x-axis, and as I go to, let's say, this point, if I draw another tangent here, that tangent will make more angle with the positive x-axis. And at x equal to infinity, almost when x is approaching very high value or very very high number, dy dx is almost infinity, because exponential e to the power infinity is almost infinity, so dy dx is infinity. That means the tangent will make 90-degree angle with the positive x-axis. That means if you draw one tangent on this graph for a very high value of x, it will be almost perpendicular with the x-axis. That is the meaning of this. This y equal to sin x and y equal to cos x. When the function is y equal to sin x, value of dy dx is going to be cos x. When the value of y equal to cos x, then the value of dy dx is minus sin x. Let's understand the first function. Second function, you can do it by yourself. Let's draw this graph, y equal to sin x. The graph will look like this. I am not drawing in the negative side of the x-axis, I am just drawing the positive side. Yx, the graph of sin x will look like this. Just one cycle I am drawing. The value of y is becoming 0 at the value when x equal to pi. The value of y is 1 when x equal to pi by 2. The value is again becoming 0 at x equal to 2 pi. Y is becoming minus 1 on the negative side of the y-axis when x value is 3 pi by 2. Now see, the dy dx, so the slope of the graph is cos x. That means if I draw one tangent, let's say I want to draw one tangent at x equal to pi by 2. That means I have to draw the tangent like this. Again, let's say I want to draw one tangent at x equal to 3 pi by 2. The tangent will look like this. So see, both of these tangents are making 0-degree angle with the positive x-axis. That means at x equal to pi by 2, your slope should be 0. Or that means the angle, if the angle made with the positive x-axis is theta, then the value of theta should be 0, because that time only dy dx will be 0 if theta is 0. That means the tangent should make, these two tangents should make 0 degree angle with the positive x-axis. Now let's study that. At x equal to pi by 2, the value of the slope should be 0. Now you put the value of x to be pi by 2. You are getting ultimately cos pi by 2, that is 0. From the graph also it is evident. At x equal to 3 pi by 2, the value of slope is cos x. You have already found it. So cos of 3 pi by 2 is also 0. So whatever formula we have learned, that we have also validated with our graphical understanding. Now see, these two tangents are making 0 degree angle with the positive x-axis, so the slope is 0 at these 2 points. Now let's find out the maximum value of the slope of this graph. Now see, the slope of this graph is cos x. Slope of this graph is cos x. So when the slope becomes maximum, when the value of x becomes either 0 or 2 pi, like that. So either at 0 or 2 pi, and in the negative way it is also maximum at pi, because in the negative way, but it is still maximum. The slope is also, the steep tangent you can make, you can draw. Now see, at x equal to 0, if you draw one tangent, this is going to be just tangent, and this tangent, if you draw here, it is becoming less steeper, and ultimately at x equal to pi by 2, your tangent is exactly horizontal or it is parallel to the x-axis. Then again, if I draw tangent, let's say here, it is becoming also steeper, but in the negative direction, that is okay. At x equal to pi also, it is becoming steeper, but at the negative way. So your tangent is making how much angle? At x equal to 0, if you draw one tangent, the slope is becoming 1. That means the angle of the tangent it will make with the positive x-axis is 45 degree. Similarly, at x equal to pi, if you draw one tangent, that tangent should make how much angle? Cos pi equal to minus 1. That means it will make minus 45 degree angle with the positive x-axis when you draw one tangent at x equal to pi. Similarly, if you draw one tangent at x equal to 2 pi, this will again start repeating the same pattern after one cycle. This is one cycle. After the one cycle, it will start repeating the same pattern of slopes as well as for the y values. So this one you try to verify by your own using the graphical knowledge, whatever you have learned. Now we'll study the chain rule. Let's say y is given as f of g of x, that means function of a function. Then how to do the differentiation? Then dy dx will be f dash of gx, whichever is there, multiplied with g dash x. Now it may be looking difficult. Let me give you one example, that is, let's say y equal to sine of ax, where a is a constant. Then see, ax is also a function of x and sine is also a function of x. So we can write in the form of f of g of x. So dy dx is going to be, first you will do the differentiation of the outer function. Sine x, just consider this as x. Sine x differentiation is cos of x. But see, inside something is multiplied with x. That means you have to again differentiate the only inner function, that is ax, with respect to x. And d dx of ax you have to do. Now if a is a constant, whenever there is some constant, it will come out of the differentiation and you will only differentiate this one. So ultimately it is becoming a cos ax. That's the chain rule. Now let me give you another example. Let's say y equal to sine of cos x. How to do the differentiation? Sine of cos x. Then first we will differentiate the outside function, that is sine. So dy dx is going to be, you know that sine x, if you differentiate, you will get cos x. So sine of cos x, if you differentiate, first term will get cos of cos x. Because whatever term is there inside, you will not consider that. You will first only consider the outside function, that is sine, cos of cos x. But as the inside function is not exactly x, it is cos x, some function of x. then you have to again differentiate, multiply with the differentiation of the inside function also. That means you are getting cos of cos x, and differentiation of cos x is minus sin x. So your answer is minus sin x multiplied with cos of cos x. That should be your answer. If I give you another example, let's say y equal to e to the power sin x. Now dy dx will be, first you have to write the outside function differentiation, that is e to the power sin x. What you do, e to the power x if is there, it is differentiate e to the power x, and the value is e to the power x only. So e to the power sin x also it will take the same value, e to the power sin x. But this function is not x, it is sin x, some function of x. So you have to multiply the entire term with differentiation of the inside function, that is sin x. So your answer is becoming e to the power sin x multiplied with differentiation of sin x is cos x. So this is the answer, dy dx. That is the chain rule, and we will go on. Okay, now very easy function. Let's say y equal to 2x plus 7 to the power 5. How to do the differentiation? So dy dx, this is one function, but outside, what is the actual function? This one you will take as variable. That this 2x plus 7 you will take it as variable. So whenever you get, let's say x to the power 5, what we do? Dy dx is 5 x to the power 5 minus 1, that is 5 x to the power 4. So here also do the same thing, that is 5 into 2x plus 7 to the power 5 minus 1, that is 4. But this function is not x, this function is 2x plus 7. So you have to multiply the entire result with the differentiation of the inside function, that is 2x plus 7, let's say. So you are getting 5 into 2x plus 7 to the power 4 multiplied with ddx of that is 2 will come outside, so 2 plus differentiation of a constant is 0 because the slope is always 0. So it is becoming 10 into 2x plus 7 to the power 4. That is the value of the differentiation. That is the chain rule. Now quickly we will learn the product rule of differentiation, and we will end with this topic, product rule. We are trying to cover only the topics important for physics. There are many other things in differentiation than this. You should learn by yourself. Product rule, let's say y is, which is the product of two functions of x. Let's say it is sin x multiplied with x, or x into sin x. How to do the differentiation? Now see, when there are two functions, one is sin x, another is another function of x. First you will differentiate one function keeping the other function intact or constant. Then you will keep one function constant and differentiate the other function, ddx of x. That is the product rule. Now this one, ddx of sin x, so the differentiation of sin x is cos x multiplied with x plus sin x into differentiation of x is 1. So ultimately the answer is becoming x cos x plus sin x. That is the product rule. Let's take some more examples. Let's say y equal to sin x or e to the power x sin x. Y equal to e to the power x sin x. Then dy dx is, there are two functions, one is e to the power x, another is sin x. So first we will differentiate the first function ddx of e to the power x, keeping the other function constant, plus first function constant, just differentiate the second function. So that is e to the power x sin x plus e to the power x. So ddx of sin x is cos x. So this is your answer. E to the power x, if you take common, it is becoming e to the power x into sin x plus cos x. Now let's take another example. Let's say y equal to e to the power x by x. So there is something called division rule, but this rule is enough because division is also a kind of product. So dy dx is, there are two functions, one is e to the power x, another is 1 by x. So you can rewrite this as e to the power x into 1 by x. So you got two functions of x. So dy dx is going to be, first one you will keep as constant, differentiate the second one, plus second one will keep as constant and differentiate the first function. So ultimately you are getting e to the power x, the ddx of 1 by x is minus 1 by x square plus e to the power x by x. That is your answer. Now there can be product of three functions, but that time you have to do is one function you will differentiate keeping the other two constant, then you will repeat the same thing as long as all the functions are not differentiated. Let's take one small example. Let's say y equal to x sin x into e to the power x. This time what you should do, dy dx is, so this function will differentiate first keeping the other two constant, that is ddx of x is 1 multiplied with sin x into e to the power x. Now we will keep this two constant, differentiate only the middle term x e to the power x, middle term differentiation is cos x. Now you want to differentiate the third one keeping the first two terms constant, so x sin x multiplied with the differentiation of e to the power x, e to the power x only. So this entire thing is your dy dx of this function. That's how you should proceed.